All right, so welcome to the part 4 of PHY101 RHEMA. Okay, so in this part, I'll be solving exam-based question from chapter 8 and chapter 9. Okay, so let's start with very first. Let's start with the very first question, which is question 1. In question 1 they said during an acceleration, the average speed of an engine increases from 900 RPM to 4000 RPM. Okay, so to 4000 RPM in 7 seconds. So they say what is the average acceleration of the engine? Okay, so if to solve this question is very easy. Okay, so let's go back and read the question. I said during an acceleration, the angular speed of an engine increases from 900 RPM to 4000 RPM in 7 seconds. What is the average acceleration of the engine? Okay, so if you look at the option, you find out that the unit of the acceleration is in rad per second square. Okay, yes. Now before we continue, now what is RPM? RPM means I've taught this under conversion factor. Okay, so you can go check it out. Okay, so that is how to convert. Okay, under angular conversion. Okay, so now RPM means revolution. Okay, means revolution per minute. Okay, yes, it means revolution per minute. Normally to calculate for angular to calculate for acceleration, to calculate for angular acceleration is very easy. Normally angular acceleration is equals to change in angular velocity divided by what? Time. So this is the formula for angular acceleration. Angular acceleration is rate of change of angular velocity with time, right? Yes. Now, so we are looking for what? We are looking for angular acceleration, right? So what are we going to do normally? We'll do something like this. Because if you look at it, W1, we have two velocity here, angular velocity. The very first angular velocity is 900. The second angular velocity is what? Is 4000, right? So R1 is equal to what? 900 RPM, right? I mean W1 is equal to 900 RPM. Then W2 is equal to what? 4000 RPM. On a normal note, we all know that angular acceleration is equal to change in angular velocity, which is change in angular velocity, right? Which is W2 minus W1 divided by what? Divided by T, right? Yes. We impute our 4000 here, we impute our 900 here, we subtract, then power time, we get our angular acceleration, right? Yes. So that is what we are going to do now. But the confusing part here is this unit. I don't understand, because if you look at our answer, our answer is in what? The answer is in rad per seconds. And if you look at the unit of the velocity, find out that is in revolution per minute. So we need to convert from revolution per minute to rad per seconds before we solve our acceleration. So which is very easy. Okay, so what are we going to do? We need to convert 900 revolution per minute, which is RPM, to what? To rad per seconds, right? Yes. We need to convert 4000 revolution per minute to what? To rad per what? To rad per seconds, right? Yes. So how are we going to do this? It's very easy. Okay, so this is under let me clear here. So this is under conversion factor of angles. Okay, yes. So let's do it. Just take note that this is very important. Take note that 2 pi radian, this is conversion factor for angle. Okay, 2 pi radian is equals to 1 revolution. Okay, yes, 1 revolution. What is one revolution? That is 360 degree, right? Yes, 360. So 2 pi radian is usually equals to 1 revolution. Okay, yes. Okay, so now if you look at the angular velocity, it is in what? It is in revolution per minute, right? So 900 revolution per minute. So this thing is still the same thing as well. Remember, RPM, which means revolution per, this per is something as what? Like this, then minute, right? Yes. So So let me do it again. So 900 RPM still something as what 900 R per minute, right? Yes. So let me clean it now. So let's do like this now. 900 R per right? Yes, it's something as what RPM. RPM means revolution per minute. So this one is revolution then per minute, right? Yes. Now this one is still something as what? It's still something as what? 900 revolution dividing what 1 minute, right? Yes. We want to we'll convert this revolution to what? To rad. Then we'll convert this minute to what? To seconds. We divide our answer. We divide our answer to get our value in what? In rad per seconds, right? Yes. So let's convert let's convert revolution per minute to what? To rad per seconds. Okay. Yes, we want to convert this revolution per minute to what? To what? Rad per seconds, right? Yes, you want to use this. Want to use conversion factor. Now let's go. So now let's go. So let's do time first. 1 minute. We want to convert it to seconds. 1 minute is still something as what? Still something as what? 60 seconds, right? Yes, still something as 60 seconds. So we are done with the time, right? Yes. Now worry about 900 revolution. Now let's convert 900 revolution to what? To radian. So it's very easy. So let's do it. You do like you say if look at it, 2 pi radian still equals to 1 revolution, right? Yes. You say okay, if 1 revolution is equals to what? 2 pi. Remember, we want to convert from what? Revolution to what? To radian, right? So if you do like you say if 1 revolution is equals to what? 2 pi radian, then 900 revolution will equals to what? An s radian, right? Yes. This one will cancel this or anyone. So let's just continue. Okay, so cross multiply, right? Yes, 1 will be multiplying s. 2 pi will be multiplying what? 900, right? So 1 times s will give us s. Then 900 times 2 pi. 900 times 2 pi. Remember, pi is what? 3.142, right? Or 22/7, right? So 2 times 3.142, that is 6.284, right? Yeah, so 900 times 6.284 times 6.284 is let me see, is 5,655.6 radian. Okay, so we have successfully converted from what? We have converted 900 revolution to what? To radian, right? So 900 revolution is still something as what? 5,655.6 radian, right? Then we'll take our answer. Here. 5,655.6 radian, right? So we'll divide, okay? Yes. So we'll divide. Let's divide now. So let's divide it. Divide by 60 seconds. So we now get 94.26. So 900 revolution per minute, per 1 minute is setting as what? Setting as 94.26 rad per seconds, right? Yes. So that is it. So that is how we do it, right? I hope you guys understand. You understand better. Let's do the other one. Remember, there are 2 angular velocity, right? So one of the 2 angular velocities are in RPM, right? Revolution per minute. So we have converted 900 revolution per minute to what? To rad per seconds, right? Yes. So we are also going to do this same thing, okay? For this other one, 4,000 revolution RPM. I remember RPM is set as what? Revolution per what? Minute, right? So I can say 4,000 rav per what? Per minute, right? Yes. Now this 4,000 rav per minute is still setting as what? Still setting as 4,000 revolution dividing what? 1 minute, right? Yes. Let's not forget about this answer. Let me just keep it to one side. Okay. So what are we going to do next? We need to convert this 4,000 revolution to what? To radian. Then 1 minute to seconds. Once we get our value, we divide them, right? Yes. So let's convert 4,000 revolution to radian. It's very easy. You say, okay. You say if 1 revolution is equals to what? 2 pi. How many radian? 2 pi radian, right? Then 4,000 revolution will equals to what? An S radian, right? So if we cross multiply, 1 times S will give us S. 4,000 times 2 pi. Now what is 4,000 times 2 pi? Remember, pi is 3.142. So 2 times 3.142 is 6.284. So 6.284 times 4,000. So 4,000 times 6.284 will give us, yes, will give us 25,136 radian. Okay, so 25,136 radian, right? Yes. So we have converted 4,000 revolution to how many radian? To 25,136 radian. Are we done yet? No. What about minutes? Let's go 1 minute to what? Seconds, right? How many 1 minute is still setting as what? Still setting as what? 60 seconds, right? Yes. We divide our answer, right? Yes. We get our true value, we divide it, right? To make it to be in what? To make it to be in radian per seconds, right? So let's divide this out. Let's divide this our value. So divide by 60 seconds. We now get what? 418.9 rad per second. So okay, 418.933 rad per second. So 418, okay, 418.933 rad per second, right? Yes. So we are done with the hard part, right? Yes. Now what are we looking for? We're looking for what? The angular acceleration, right? Remember, angular acceleration is equal to what? Change in what? Angular velocity divided by time, right? Yes. So change in angular velocity means what? Means W2 minus what? W1, right? So angular acceleration equals to W2 minus W1 divided by T. So what is our W1? Our W1, our W2 is what? Is 418.933. Our W1, our W2 is 418.933. What about W1? W1 is what? 94.26 rad per second, right? So impute the values. Okay, so let's impute the values now. So angular acceleration because what? Our W2 is what? 418.933. Then W1 is 94.26, right? Divided by what? T. What is time? Time is what? Time is 7 seconds, right? So that by 7 seconds. So if we do, what will be our answer? Now I want to just use calculator to do it straight. Okay, so let's do it. Okay, let me be fast. So 418.933 then minus 94.26 divided by 7. So my answer is 46.38. So the answer is what? 46.38 rad per second square. Okay, so this is the answer, 46.38. So A is gone, B is gone, C will be the right answer, 46.38 rad per seconds. So I think if we leave out, yes, so we are good to go, right? Yes, so that is this. So C is the right answer, right? Yes. So that is how you do it, okay? Yes. Now let's move to the next question. Question 2. Okay. So question 2. They said, okay, a baseball of mass. So let me draw it again. A baseball. They said this is a ball. Then the mass of the ball is, they say a baseball of mass 0.145 kg. 0.145 kg. Right? The mass is moving in the, you see this plus, in the positive S direction. So this is positive S direction, right? Yes. Okay. Positive S direction with a speed of what? 3.4 meter per second. So this speed is what? 3.4 meter per second. It's moving to this side, right? Yes. And a tennis ball of mass 0.0570. Okay, this is a tennis ball. The mass is 0.0570 kg. Okay, it's moving in the, look at it. This, you see this negative, then negative S direction. That is negative S direction is this side, right? Yes. So it's moving to the negative S direction with what? With a velocity of 6.20. So velocity of what? 6.20 meter per second, right? Yes. They say what are the magnitude and direction of the total momentum of the system? Remember, total momentum of the system is equals to momentum of this first body. Let's call this body A, because it's one body B. Okay, so total momentum is equals to momentum of the first body, momentum. Okay, momentum of body A, then plus momentum of body what? B. So the total, so that is the total momentum of the system, right? Yes. Remember, what is momentum generally? Momentum, let's look for momentum of PA, then let's look for momentum of PB. So PA is equals to what? Remember, what is momentum? Momentum of a body is equals to what? The mass of that body times what? The velocity, right? Remember, momentum is a vector quantity. So momentum of a body equals to the mass of that body times the velocity of that body, right? Yes. So times the velocity with which the body is moving, right? So now let's look for the momentum of body A. So what is the mass of body A? Is what? 0.145. Then times the velocity. The velocity is what? 3.4, right? The velocity is a positive velocity because it's going in the positive x direction. So let's multiply it. So 0.15, so 0.15145 then times 3.4. So the momentum of this body is what? Is 0.493. So 0.493 then plus, let's look for momentum of body B. Okay, let's look for momentum of body B. So okay, body B. Now what is the mass of body B is what? 0.0570, right? Then times the velocity. Look at it. The body is moving what? This body is going to negative x direction. The velocity is moving to a negative x direction. Therefore, the velocity is what? Negative, right? So this mass times what? This velocity is what? Negative, right? So times minus 6.20, right? So if we times it, if we multiply, what will be our answer? So let's do it. So 0.0570 and times minus 6.20. Our answer will be minus come, let me see. Okay, all right. So our answer will be minus 0.3534. Okay, so minus 0.3534. Okay, so take it here. Okay, so bracket open, minus 0.3534. So let's add everything. Let's what will be the total momentum of the system. Okay, so let's do it. Okay, so let's do it. So let's do it now. 0.493, then plus bracket open minus, right? 0.3534. So our answer will be 0.114. Okay, yes, our answer will be 0. I have 0.139. So if I approximate, it will be 0.13, it will be 0.14. Okay, so our total momentum is what? Our total momentum in system is what? Total momentum in system is 0.1396. So if we approximate, it will be what? To be 0.1. Approximate this 9 to be what? 4, right? So this is the answer, 0.14. Now remember, does this value take minus? No, it's plus, right? Yes. So let's go to the option. So A 0.14, you see it's negative. Negative x direction. Is that true? No. And if they collide, they will move in this direction. If you look at it, total momentum in system after they collide, you look at it, it's positive, right? When we solve it, we get positive answer, right? 0.14. So that's to tell you that after they collide, they'll move to the positive x direction. So A is not correct. Now B is not correct because our answer is 0.14, not 0.41. Then C 0.41, no, C is not correct. Then D 0.14, then you see this plus positive x direction, right? So that is the right answer, which is D. Okay, yes, the body, if after they collide, they go in the positive x direction. Okay, so now let's move to the next question, question 3. Okay, so question 3, let me solve that one. Let's do it. Okay, I think it's still under momentum. Okay, now they say a truck moving to the right. So this is a truck moving to the right with a speed of what? 5 meters per second. Hits a car. Let's say this is a car. Okay, this truck hits the car with a speed. The car moving with a speed of. So this car is moving with a speed of 4 meters per second. Okay, so this truck moving with a speed of 5 meters per second hits a car moving towards the velocity of 4 meters per second, right? In the same direction, they are moving in the same direction, right? They say after collision, after this one hits this guy, after collision, the truck, after they collide, okay. So after this truck, remember the truck was moving with a velocity of 5 meters per second. The truck hits a car moving with 4 meters per second, right? So after the truck hits the car, so let's continue. So they said after collision, which is after the truck hits the car, the truck and the car move with. Okay, so the truck, after it collide with this guy, the truck and the car move with a speed of 4 and 3 meter per second respectively. So after the truck hits the car, the truck starts moving with a speed of 4 meter per second, 4 meter per second, while the car start moving with a speed of what? With a speed of 3 meter per second, right? 3 meter per second, right? They said determine the coefficient of restitution of the collision. Okay, yes. So coefficient, now this is a very easy question. So remember, coefficient of restitution of uh, of okay, coefficient of restitution of collision usually equals to relative velocity of final collision. Okay, it's equals to what? Relative velocity after collision divided by relative velocity before what? Before collision, right? Yes. So E will be equals to, now let's call this after they collide, right? Yes, after collision, right? After collision, right? Yes. Now why this one is what? Before they collide, right? Before collision, right? Yes. So before they collide, before collision, I'm coming. Okay. So before collision, where is the initial velocity? This is the body one, this is body two, right? Body one, body two, right? So where is the initial velocity before they collide? What is the velocity of the truck? The initial velocity is what? Is 5. Now worry about this guy, the initial velocity, body two. The initial velocity of body two is what? Is 4, right? That is how before they collide. Now after they collide, what is the final velocity of body one? The final velocity will be what? 4. Then the final velocity of what? Body two will be what? Will be 3. So now let's continue. If this, which coefficient of restitution is equals to what? Is equals to V2 minus V1 divided by V1 divided by U1 minus U2. So please don't miss this up, okay? It's very, very important. Okay, so yes, so coefficient of restitution is equals to V2 minus V1 divided by U1 minus U2. Is very important, don't miss it up. So V2 is what? V2 is 3. Then V1 is what? V1 is 4. Then divided by U1 is what? U1 is 5. Then what about U2? U2 is what? 4. So 3 minus 4 will give us minus 1. 5 minus 4 will give us 1. So 1 divided 1 will give us 1. Don't forget about this minus. So minus 1 divided 1 will still give us minus 1. So the answer is what? The answer is minus 1, which is C. Okay, so that is it. Now let's move to the next. Please don't forget, don't miss this up. Okay, V2 minus V1 divided by U1 minus U2. So the next question, question 4. All right. And please don't forget to subscribe. It's very important. Okay. So now let's move to the other question. Question 4. Okay. Okay. Question 4. Now let's continue. I said, here. All right. So question 4. They said a particle turns around the cycle with acceleration of, the acceleration is 5 meter per second square, right? Towards the center, given that the radius of the cycle, radius is 5/9 meter, right? They say find the angular velocity. We are looking for W. Okay, so it's very easy. Okay, so we all know that acceleration is equals to what? We all know that acceleration is equals to v square over r, right? Yes, acceleration is equals to what? W square r. Okay, so we are using this formula to solve. Okay, what are we looking for? They gave us A, they gave us r. We are looking for W. So A is what? A is 5. Then equals to W, we don't know, right? R is what? 5/9, right? So if we cross multiply, so R square times, W square times 5 will give us 5W square divided by 9, right? Right? Or let's just cross multiply. So if we cross multiply, 5 will multiply 9, then this one will multiply this. We have 5W square, right? We're looking for W, right? We're looking for W, so we divide this by 5. Okay, that goes out by 5. This one will cancel this. This 5 can cancel this one, right? So we left with 9 equals to W square, right? W square equals to 9, right? Now, we're looking for W. So what are we going to do? we take the square root of both sides, right? Yes, so this square root cancel this square, then the square of 9 is what? Is 3. So the answer is what? Oh my god. Oh my god, I didn't read the question fully. Well, oh my god. So let's continue. They said, find the angular velocity in revolution per minute. Okay, so let's continue. We got our velocity is what? Is our angular velocity is what? Is 3 what? Angular velocity is what? Is 3 rad. Remember, this SI unit for angular velocity is what? Rad per second, which is radian per second, right? So when we solve, our angular velocity is what? 3 radian per what? Seconds, right? So look at the answer. They said find the angular velocity in what? In revolution per minute. Okay, so we need to convert this rad per seconds to what? To revolution per minute. So it's very easy. So this thing is still setting as what? It's still setting as what? 3 radian dividing what? 1 seconds, right? Yes. So convert this 3 radian to what? To revolution. We convert this 1 seconds to what? To minute, right? Because they said leave your answer in what? Revolution per minute, right? Yes. So according to that conversion factor, we all know that we all know that 2 pi radian is equals to how many revolution? 1 revolution, right? Yes. So let's convert this 3 radian to revolution. It's very easy. We'll say if 2 pi radian is equals to how many revolution? 1 revolution, then 3 radian will be equals to what? An S revolution, right? Yes. Or you can turn it. You say if 1 revolution is equals to how many radian? 2 pi radian. Then an Hertz revolution will be equals to what? Equals to 3 radian, right? Cross multiply, so it's the same thing, right? So you can turn it as long as the values with the same quantity are on the same side, we are good to go. So 2 pi radian is equals to 1 revolution. Then if 2 pi radian is equals to 1 revolution, then 3 radian will be equals to what? An Hertz revolution, right? So if we cross multiply, 2 pi times S will give us 2 pi S. 3 times 1 will give us 3, right? So S will be equals to what? S will be equals to, I'm coming. So we're looking for S, right? So divide both sides by 2 pi. So 2 pi. So this one will cancel this. So S is equals to what? Is equals to 3 over 2 pi revolution, right? Remember, our answer is in pi. So that's why I didn't convert this pi to 3.14, right? Yes. So we have converted from what? We have successfully converted 3 radian to how many revolution? 3 radian is setting as what? How many revolution? 3 over 2 pi revolution, right? Yes. Now let's convert 1 minute to what? Well, let's convert 1 seconds to what? To minutes. It's very easy. So how are we going to minutes? So how are we going to do? We'll say, okay, if 60 seconds is equals to what? How many minutes? 1 minute. Then 1 seconds equals to what? An S minute. That's what we cross multiply. So 60 times S will give us 60S. Then 1 times 1 will give us 1. We're looking for S. That goes out by 60. Right? So S will be equals to what? 1 divided 60, right? So let's do it. 1 divided 60. So what is so 1 divided 60 will be what? 0.01667. Okay, so 0.01667 minutes. Okay, 7 minutes. Okay, minutes. Okay, so 1 second is still sending as how many minutes? Still sending as 0.01667 minutes, right? Yes. Okay, 0.01667 minutes, right? Yes. What I'm going to do next, we divide our two values that we got, right? So let's divide it. So let's divide it. Remember, we leave our answer in what? We leave our answer in if you look at the option, the answer is usually in what? Is in terms of pi. So we are not going to convert this pi. So let's do it now. Okay, so let's do it. So this 3, so we are dividing this two, right? So 3 divide 2 pi revolution is dividing how many? Is dividing this one, right? So we can do it like this: divide 0.01667, right? Yes, right? Right? Yes. Okay. Okay. So what next? Now let's continue. Let's continue. Okay. So I will go. Let's simplify this further. Okay. Minutes. Don't forget about the minute. Okay. So this one is setting as what? according to mass, if we turn this to multiplication, this one will come up, the other one will come down. All right. Yes. So let's do it. So 3 divide 2 pi. 3 divide 2 pi revolution, right? Then times this one will come down, this one will come up, right? So 0.01667, right? So this one times this. So 3 revolution times 1 give us 3 revolution. Then 2 pi times this one. So let's do it. 2 pi times this. 2 pi times this. Let's just use calculator straight. Let's not stress ourselves. So let's just do it. Turn into fraction mode. Then still turn into another fraction mode. So 3 divide what? 2. Then pi. Okay, then divide by what? Okay, we are not going to convert this pi. I'm coming. Okay. Okay, then divide by this one. Divide by 0.01667. Okay. So my answer here that I got here is, when I divide it straight, is 90. Okay, is 90 divided by pi. All right, so the answer is 90 over pi, which is A. But let's do it. Okay, so let's just continue with what we were doing before. All right, so where were we? Okay, so let's do it again. Remember, we landed with something like this, right? So this one, so this thing see setting as what? 2 pi revolution dividing what? 0.01667, right? 667 minutes, right? Yes. So this one divided on give us the same thing, right? Yes. So we want to remove this division sign to this multiplication sign, right? Even to this multiplication sign, this one will come up, this one will come down, right? Yes. This one will come up, this one will come down. So now it's something like this. 3 revolution divided by 2 pi times what? This one will come down, this one will come up, right? Times 1 divided by what? 0.01667, right? 1 times 3 revolution will give us 3 revolution. Then 2, remember, our answer will be in terms of pi. So 2 times this value here. Okay? So 2 times this value. We will not turn pi to 3.142 because look at it. Our answer is still in pi. So we're not going to convert pi to 3.142. So 2 times this value here. So 2 times 0.01667 is what? Okay, 0.01667 is what? Is 0.03334. Okay, so 0.03334, right? Yes. Okay, then don't forget about the pi, right? Yes. So what I'm going to do next, just do it. 3 divide this one. 3 divide this one. Let's see what we our answer. Okay, remember pi is at the denominator, right? So let's do it. 3 divide this one. 3 divide 0.03334. Our answer is 89.9, which is 90. So if we do it, now we got 90 revolution divided by what? Pi, right? This 3, if we divide this one, we get to now be 90. Then don't forget about the pi. So the pi is still at the denominator. So the pi is still at the denominator. So now we got 90 revolution divided by what? Dividing pi in minutes. So the answer is what? A. Now let's move to the next questions. So now let's continue with these last few questions, okay? So that's question 5. They said the angular momentum of a rotating free wheel is given by one of the expression. Okay, remember we have normally we have angular, should I say angular parameters? We also have linear parameters. Okay, yes. In rotational motion is different from linear motion generally. Okay, so let's say this for rotational motion. Okay, let's say these are the parameters. Parameters for rotational motion, then parameters for linear motion. Okay, yes. Now the parameters we use in linear motions, they are analog to those we use in rotational motion, or should I say the parameters we use in rotational motion are analog to the parameters we use in linear motion, vice versa. Okay, now let me explain. Now in linear motion, velocity is velocity, right? V. But in rotational motion is known as what? Angular velocity, right? Yes. Yeah. In linear motion, distance or displacement is d, right? Displacement or distance, right? It is called displacement or distance. But in rotational motion, it is called what? Angular displacement or angular distance. Okay. Yes, there are many. In linear motion, we have acceleration. In rotational motion, it's known as what? Angular acceleration, right? Yes, so and many more. Okay, in linear motion, momentum is equals to mass times velocity, right? But in rotational motion, it is known as what? Angular momentum, which is equals to what? Now, before I continue, there's one thing to tell you guys. Okay, so you guys understand this. Now, let me continue. I'll come back to this place. Now, just as in linear motion, we have mass. We have mass generally. We have mass, right? M, right? Now in rotational motion, it is known as moment. It is known as moment of inertia. Okay? Yes, it's known as what? Moment of inertia, and it's presented as what? As I, letter I. Okay? Yes. Now just as we have velocity in linear motion, in rotational motion to be what? To be angular velocity, right? Yes. So that's to tell you that angular velocity is analog to what? Linear velocity, right? Yes. So they are analog, right? Yes. In linear motion, we have linear acceleration, or we can say acceleration. In rotational motion, it is known as what? Angular acceleration, right? Yes. Now, in linear motion, or we can see in linear terms, this guy is called mass, right? Yes. Now, the analog of mass in rotational motion is known as a moment of inertia. It is represented by what? I. Now, let's go back to momentum. We all know that in linear terms, momentum, which is presented by letter P, is equals to mass times velocity, right? Yes, but we all know that in linear term, velocity is velocity. In angular terms, known as what? Angular velocity, right? Yes. Now, look at momentum. Momentum is P equals to mass times velocity, right? This is the symbol, mass times velocity, right? Yes. Now, what about this? This will not be what? This is linear momentum, right? So, in rotational parameters, in rotational motion, it's not known as what? Angular momentum, right? In linear terms, it's known as what? Linear momentum. It's equals to mass times velocity. In rotational term, it is known as what? Angular momentum, right? It will be equals to what? Now, what is analog to mass in rotational motion? Remember, momentum is equal to mass times velocity, right? Yes. Now, what is analog to mass in rotational motion? It is what? Moment of inertia, which is represented by I. So, angular momentum will not be what? Will not be moment of inertia times. Now, we know that moment is equal to mass times velocity. So where is the analog of velocity in rotational motion? It is what? Angular velocity, right? So now be what? Angular velocity. So let's say that linear moment is equal to mass times velocity. Then angular moment is equal to what? Moment of inertia times angular velocity, right? So it's equal to what? IW. So let's go back to this place. I said the angular momentum of a rotating flying wheel is given by one of the expression, which is what? B, right? Yes. Moment of initial times angular velocity, right? So that is very easy, and there are more. Okay. So let's continue. Question 6. It said calculate the radius of gyration of a uniform rod of mass 20 kg and length 6 meter. Okay. So radius of gyration. Okay, you can go watch, and to know more you can go watch our videos under rotational motion. Okay, yes, I think I talked about radius of gyration. Generally, moment of inertia. This is under rotational motion. We all know that moment of inertia presented by I. The formula for moment of inertia is equals to, generally, is equals to mass of the body times what? Times the square of the radius, right? Yeah, this is moment of inertia, right? Yes. Okay, so this one has moment of inertia, this is mass, this is radius. So moment of inertia is equal to mass times the square of the radius, right? Yes. Now, there's what we call radius of gyration. Yes, if I can still remember, radius of gyration, it is a constant. It is a constant, okay? So in the place of this arrow, we'll move this arrow and place what? K. This radius of gyration, I think it is the, I think it is usually the distance. I think from, let's just continue though. I've forgotten, but let's just continue. Just on that, in the place of, we know that the moment of inertia equals to mass times what? Mass times mass times the square of the radius, right? Yes. Now there's what we call radius of gyration. Okay. Yes. Yes, the radius of gyration is usually a constant. Okay, it's usually a constant. I think it's usually a constant distance between. I think between the particles from, I don't know, but let's just continue. Okay, so moment of inertia is equal to mass times moment of inertia is equal to mass times of the body times radius square of the radius, right? Yes. So in the place of, we are looking for radius duration, is an assumption, okay, and it is a constant, right? So in the place of this arrow, I put what? K, right? Yes. Now let's look for K is known as radius of duration. Now let's make K stand alone. Let's make K stand alone by dividing both sides by one M, right? Yes. So this one will cancel this. So K square because to what? Moment of inertia dividing what? The mass of that body, right? Yes, we are looking for K. So take the square root of both sides, right? So square root of both sides. So K is equal to what? Root. Moment of inertia over mass. So this K is known as what? K is known as the radius of gyration, okay? Yes. So this is formula for radius of gyration. Very important, okay? Now let's continue. I said calculate the radius of gyration of a uniform rod of mass 20 kg and length 6 meter. Okay. Now the moment, now take note that look at the question very well. Uniform rod. Now the moment of inertia of a uniform rod normally is 112 the mass times the length times the square of the length. Okay. Yes. So this is the moment of inertia of a what? Of a uniform rod. Okay. The moment of inertia of a uniform rod, right? Yes. What are they telling us to look for? They're asking us to look for what? The radius of duration of what? Of a uniform rod, right? Yes. So let's continue. We say K. After this formula, K is equal to root. Now, where is the moment of inertia of a uniform rod? This is moment of inertia, right? Moment of inertia of a uniform rod is what? Is 112 mass times the square of the length, right? Yes. So I'll put that this out. I'll say, okay, 112 the mass times what? The square of the length, right? Divided by what? Divided by mass, right? Yes. This mass will cancel this mass. So left with what? Root 112 then L square, right? Yes. So K will be equals to what? Root 1 times L square, so give us L square, right? So K will now be equals to L square divided by what? 12, right? Yes. Now this square can cancel this square. This square can cancel this square, right? Right? Yes. Don't forget that this square root also affects 12. Oh. Since this square cancels this square root, only 12 will now be affected. So K will now be equals to what? L divide root 12, right? I hope you guys understand. Okay, so let me clean it again. Let me be fast. Let me explain it again. Okay, so that's what we calculate for the what? For the radius of gyration of a uniform rod. Okay, before we solve for the radius of gyration of a uniform rod, we need to know the momentum. I say momentum. The the moment of inertia of a uniform rod. Now the moment of inertia of a uniform rod is this, right? So in place of this, I'll put this in place of I, right? So now be what? K is equals to what? Root. I is what? 112, right? ml squared divided by what? This mass, right? This mass cancel this. We'll be left with what? We'll be left with K is equals to root 112 times the square of the mass, right? Yes, root 112 times the square of the mass. I mean, root 112 times the square of the length, right? Yes. Now, 1 times the L square will still give us L square, right? Then divided by what? 12, right? Now, so you see this square will cancel this square root, right? So remember, this square will still affect, 12, right? So K will now be equals to what? L divided by root 12. So let's solve K. It's very easy. Now, what is the length? What is the length? Length is 6, right? Length is 6, then root 12. So let's do it. Let's just simplify it with calculator. We'll get our answer here. So it's very easy. That's just it. Okay, so let's do it. 6 divided root 12. Root 12. Okay. 6 divided root 12 is the same thing as root 3. Okay, the tray in calculator is the same thing as what root 3. Okay, so the answer is D, same thing as root 3. Okay, or if you don't want to do it like that, if you don't want to do it like that, go to your calculator, do 1 divided root 12. In 1 divided root 12, that is, do it in fraction form. Go to your calculator, press, you know that your castle calculator, you know that form in which you can put in something like this. It's something like this in your calculator. And if you press it, it will now give you fraction form, right? You put 12, then you go down, you press square root, then you put, you put 6, then you go down, you write square root, then you put 12. Yes, there's this button in your castle calculator that looks like this. Okay, if you press it, it will turn into fraction form. Then you input 6, then put square root, then put 12. Okay, yes. So if you're going to do that in your castle calculator, if you press it, you will have root 3. Then decimal form to be 1.73. Okay, so if you do it in your calculator, you have what? You have root 3 or 1.73. Right? Yes. Now you go to all this place, do everything. Which one will give you 1.73 to do what? To be root 3. Root 3 is still something as what? 1.73. Okay, so our answer is D, root 3. Okay, now let's continue. Let's go to the next question. Okay, so there's no time. So let's continue the next question. They said a flywheel of mass 1000 kg and radius of gyration 3 meter is rotating once every second. Find its kinetic energy. Okay, just like as I gave you guys linear terms and rotational terms, right? Just like we have velocity in linear term, we have angular velocity in rotational term, right? Just like we have mass in linear term, we have what? Moment of inertia, right? And so on. Now, just like we have kinetic energy to be equals to half mv square in linear term, in rotational term we have what? Kinetic energy to be equals to what? Half. Now, what is analog to mass in rotational motion is what? It is what? It is a moment of inertia, right? Yes. Now, what is the analog to velocity in rotational motion is what? It is angular velocity, right? So square. So this is the formula to calculate for what? Kinetic energy in this is known as, if this is known as okay, if this is known as, okay, this is kinetic energy in linear terms, this kinetic energy what? In rotational term. Okay, so kinetic energy is what? Half moment of inertia w square. Now we all know that moment of inertia. And let's continue. Okay, well, before then, let's continue. I said a flywheel of mass 1000 kg and radius of gyration 3 is rotating once every second. Find kinetic energy. Okay, so now what is moment of inertia? Generally, or in general, the moment of inertia is equal to mass of that body times the square of the radius, right? Yes. Now, since the radius of gyration is 3 meters, so this arrow square will be what? K square, right? Since you are using this is the radius of gyration, so that arrow square that I have, and I can say okay, K square, right? Yes, this K is known as what? Radius of gyration, right? Yes. Okay, so if you look at the question, did they give us moment of inertia? Like, did they give us directly? No, they gave us indirectly. They gave us mass. When we all know that moment of inertia equals to mass times arrow square, or mass times the square of the radius of gyration, right? Yes. So they didn't give us directly. They gave us indirectly. They gave us mass, which is this. They gave us radius of gyration, which is this, right? Then let's look for R first. So mass is what? Mass is 1000. Then times radius of gyration is 3. So 3 square, right? 3 square is 9. So 9 times 1000 is what? Is 9000. So the moment of inertia is moment of inertia is 9000, right? So kinetic energy will be equal to what? Half times what? R is what? 9000, right? Then times angular velocity, the square of angular velocity. Just know that we all know that angular velocity is equal to 2 pi over t, or 2 pi f. Okay, so angular velocity is 2 pi over t. Now if we continue, let's look at our option. Our option is in pi, right? So we'll leave pi like that. Okay. Now what is time? T is what? They say once every second. So t is what? T is 1, right? T is 1, right? So anything divided by 1 will still give you that same thing, right? right? Yes. So our W is what? 2 pi, right? So in place of W, put what? 2 pi. Then don't forget about the square, right? Yes. So let's do it now. So I hope you guys understand. We all know that W is what? W angular velocity is equal to 2 pi over t. T is what? T is 1. Then since our answer is the term of pi, we will leave it like this, right? So 2 pi divided 1 will still give us what? 2 pi. So W is 2 pi. So wherever we see W, we put what? 2 pi, right? Then don't forget about the square, right? Now the square of 2 pi is what? Is 4 pi square, right? Yes. So half times 9,000 times 4 pi square. So half times 9,000 is 4,500, right? It's 4,500. 4,500. Now 4,500 times 4. So let's do it. 4,500 times 4 is what? Is 18,000. So everything will be what? Everything will be 18,000 then pi square, right? 18,000 pi square. So this is our answer, which is C, 80,000 pi square. So it's very easy. Now let's do question 8. Okay. So question 8, they said two balls of equal mass 0.5. So let's say this is two ball. Okay, this ball has, both of them have equal mass of 0.5 kg. Okay. Then this is the other ball. The mass is 0.5 kg. Or let me do it like this. Okay, the mass is 0.5 kg. This other ball, the mass is what? Is 0.5 kg. Right? Now let's continue. Two balls of equal mass, right? These are two balls moving along the positive S and Y axis. So this one is moving along the positive X. This is positive S. That is what? This is the positive Y axis, right? Yes, okay. So moving along the positive S and Y axis at the same speed. So both of them still have what? The same speed, right? The same speed of 6 meters per second. So this one will be moving in the along the y axis is what? The speed she's moving along the y axis is what? 6 meters per second. Right? The same speed. Collide and stick together. So let's say they both collide at this point. Okay, and they stick together. They say find the magnitude of the linear momentum. So they're asking us to look at what? The momentum. Okay, it's very easy. If you look at the narration of the story, find out that if you look at the now from this question, you will see that these things is look at it. This one is coming to the point. The one of the boys going towards the positive S. The other one is moving like one of the boys moving along the positive S. The other one is moving along what? The positive Y, right? Yes. So yes. So they collide, right? At one particular point. If you look at it, this one is this thing is what? These things are perpendicular. They are perpendicular like this, right? Yes. So remember, momentum is a vector quantity. Remember, we represent vector. We have different means of representing vector. Different type of vector. We have different type of vector. We have perpendicular vector. We have diagonal vectors, right? Yes, this one will be the resultant. This one, let's say this is vector A, vector B, right? So this one is what? This one is perpendicular vector because they are perpendicular, right? So call this one vector A, for example, then you call this one vector B, right? Yes, this type of vector is known as what? These are perpendicular vectors, right? Yes, so we are looking for the momentum. So now we are looking for their momentum. We are looking for their total, find the magnitude of their momentum. Okay, so let's look for the momentum of this ball. Let's look for the momentum of this ball. Okay, momentum of this ball is what? 0.5 times 6 is what? Is 3. So the momentum of this ball is what? We all know that momentum is equals to mass times velocity, right? The mass of this ball is 0.5, the velocity is 6. So mass times 0.5 times 6 is 3, right? So the momentum of this ball is what? Is 3. Then what about this one? The same thing. The momentum is what? 0.5 times 6 is 3, right? Yes. So we can call this one we can say this momentum in y-axis. This is momentum what? Momentum in the x-axis, right? Since they are perpendicular, remember momentum is a vector quantity, and there are different type of vectors: perpendicular, diagonal, linear vector, parallel vectors, and parallel, and so on. So these vectors, these two vectors, they are what? Perpendicular. So something like this. And we calculate for the resultant. of perpendicular vector, use Pythagoras theorem, right? Arrow square is equals to what? A square plus what? B square. Or we can say y square plus what? S square. Right? So let's continue. Y is what? Is 3, right? 3 all square. Then what about s? The momentum there's that is as is what? Is 3 all square. So square of the square of 3 is 9. The square of this 3 is still 9. 9 plus 9 will give us 18. So the square of 18 is what? So let's do the square of 18. The square root of 18 rather. Square root of 18 is what? Is 4.24. So the answer is what? D. 4.24. Alright, so let's do the last question. Under part 4, okay? So the last question they said a disk of moment of inertia 5 times 10. Yeah, 5 times 10. Okay. Okay, I think it's supposed to be raised power something. Okay. Okay, so it's raised power minus 4. Okay, raised power minus 4. Okay, so they say this of moment of inertia 5 times 10 raised power minus 4. So the moment of inertia of this is 5 times 10 raised power minus 4 kg meter square. It's rotating freely in batch as 0 through its center at 40 revolution per minute. So this is angular velocity. 40 RPM, which is revolution per minute. Calculate the new revolution per minute. So we're looking for this one will be W1, then we're looking for W2, we don't know, right? Yes. Calculate the new revolution per minute. If some wax of mass 0.02 kg is dropped gently on the disc 0.08 meter from its axis. Okay. So the mass of the wax that was dropped on the disc is 0.02 kg. Now they said okay, then the distance from which the wax and the distance at which the where the wax lies from the axis is what? 0.08. So L is 0.08, or we can say arrow is equals to 0.08. What are they telling us to look for? They're telling us to look for W2, right? Yes. Now this question is coming out from angular momentum. Okay, this question is coming out from angular momentum. Okay, conservation of angular momentum. Okay, yes. So this one is coming out from conservation of angular momentum. Now, if we move to linear momentum, we all know that in linear momentum, another conservation of linear momentum is we all know that conservation of linear momentum. We will know that the momentum of we all know that total momentum. Let me use before collision for example. Now, let's say we all know that in linear terms and conservation of linear momentum state that the total momentum before let's say before collision usually equals to total momentum after collision, right? Yes, that is yes. Before, let's say we all know that conservation of momentum say that total momentum before it's something now. Okay, let's say total momentum before collision usually equals to total momentum after collision, right? I'm using in terms of collision. Okay, so we have something like the V1 because V1 M1 V1 equals to M2 V2, right? Yes, that is in linear terms. Now we still have this one. We still have that conservation of momentum say still works in angular terms as well, right? In rotational terms, right? So in rotational term, to now be what? Now I told you guys earlier that angular momentum L. We know that momentum is what? Linear momentum mass times velocity, right? It's what about angular momentum. Angular momentum will not be what? What is analog to mass? Moment of inertia. What is analog to velocity? Linear velocity is what? Is angular velocity, right? Yes. Since under this conservation of moment, right? Yes. So since we have M1 V1 equals to M2 V2, so this in angular terms is still what? I1 W1 is equals to I2 W2. Okay, yes. So that is it. Okay, so we are looking for what? We are looking for W2, right? Yes, we are looking for W2. So our I1 is what? I1, this will be I1. Now you may ask, what about I2? Now I2, I2 is, if you look at it generally, if you look at it, the moment of a disk of moment of inertia is 5. The moment of inertia of this was 5 times 10 raised by minus 4 initially. Now, but when wax was dropped, the moment of inertia increase. That is I2 now be what? Normally, initially, it was I1, right? Then wax was dropped. And the mass of the wax is this mass of the wax, then this the distance from the axis is this, right? Yes. This is the initial momentum. This is the initial moment of inertia of the disk, right? Yes. Then plus the moment of inertia of this that not remember we all know that wax was dropped, right? Since wax was dropped, the moment of inertia will now increase of the this will now increase, right? Yeah, so plus the moment of inertia of the disk, the moment of inertia as a result of the I mean plus the moment of inertia caused by the wax being dropped, right? So plus m arrow square. I don't even understand. Okay, so plus m arrow square. So I2 will be what? Initially, the moment of inertia of the disk was this. Now, but after wax was dropped, the mass of the wax then the mass of the wax added to the moment of inertia of the disk. Okay, because it was dropped, so it added. The moment of inertia will increase. This will even lead to the. This will even leads to. This will even try to slow down the rotation. I don't understand. Okay, so Act 2, which is the moment of inertia after the wax was dropped, will be what? Will be the initial moment of inertia plus the moment of inertia caused as a result of what has been dropped. So Act 2 will be what? What is I1? I1 is what? 5 times 10 raised by what? Minus 4, then plus the mass of the wax is what? 0.02, then times the distance. The distance is what? 0.08, right? 0.08 all square, right? So this will be I2. Now let's do it now. I1 W1 is equals to I2 W2, right? So I1 is what? 5 times 10 is about minus 4 times W1 is 40. Then I2 is what? See, this is I2, 5 times 10 is about minus 4 plus. Now 0.02 times the square of 0.08. So 0.02 times bracket open 0.08 bracket close all square, right? Yes, so it will be so this guy is multiplied, then take the square of this one multiplied by this to be 0.000128, right? Then times what? Then times W2, right? So we don't know W2, so that's what we're looking for. So let's add this. Okay, so let's add it plus 5 times 10 raised to power minus 4. Okay, so everything here will now be 0.00. Let me use good marker. Okay, come let me clean this place. Okay, I clean this place. Okay, so times what? Times W2, right? So if we do everything here will be what? 0.0000628, right? So this one plus this will give us this. Then times W2, put W2, right? Yes, then equals to, let's do this. Let's do it. So 5 times 10 raised to power minus 4, then times what? Times 40 will give us what? Will give us 0.02, 0.02, 0.02, right? So what I'm going to do, the double side. Remember, I'm looking at W2, right? So the double side by this 0.000628 divided by 0.000628. So I'll cancel this. So if we do it, our W2 will be what? We do it. I'm coming. Oh my god. Okay, so let me just use, okay, so let's hope we do it. 0.02 divided by 0.000628. So the answer is 31.84. So the answer will be A. Okay, so 31.84. The answer is A. Okay, yes. So please don't forget to subscribe. It's very important. Okay. Yes. So this is the end of the part 4 RHEMA on chapter 8 and chapter